Welcome to the experimental video for the synthesis of acetylacetonato cobalt 3. In a large 600 ml beaker, collect approximately 500 ml of boiling water. Place the beaker with the boiling water on a hot plate which is turned on the hot plate itself as well as at the plug on the side wall socket. This will constitute your steam bath for the first step of your synthesis. Next, in a small 100 ml beaker, collect your 2.5 grams of cobalt carbonate, CoCO3. First, tare the scale using your 100 ml beaker and then carefully weigh off your cobalt carbonate. Remember, this mass only needs to be approximately 2.5 grams. Next, you will collect 20 milliliters of acetylacetone in a measuring cylinder and using a funnel in a reagent fume hood, as illustrated in the video. Next, in your fume hood, add your acetylacetone to your cobalt carbonate and slightly swirl the solution so that you can dissolve your reagents. Next, you will clamp your reaction vessel in your water bath. To do this, take a clamp and secure it at the back of your fume hood, slightly above the water bath. Next, place your 100 ml beaker containing your reagents and place it in your clamp and lower it into the heated or the warm water such that the level of the water is above the level of the reagents in your beaker. Next, you will collect 30 ml of 10% hydrogen peroxide, again using a measuring cylinder and a funnel in the reagent fume hood. As always, this is an approximate measurement, so if you take 31 ml, that's also perfectly fine. We will now dropwise add our hydrogen peroxide solution using a dropper pipette, a plastic pipette as shown in the video. The reason this needs to be done dropwise is the reaction is quite vigorous if too much hydrogen peroxide is added at once. We will first illustrate what happens when the reagent is added dropwise, and then what happens if too much of the reagent is added at once. A dropwise addition leads to a small reaction and little gas evolution, whereas a large addition will lead to a very vigorous reaction. This vigorous reaction might lead to the reaction mixture to boil over and you needing to restart your experiment from scratch. To assist with your experimental proceedings while adding the hydrogen peroxide, you may use a glass rod to continuously stir the reaction mixture and to ensure that anything that boils onto the sides of your reaction vessel continuously is added back into the reaction mixture as illustrated here. Whether or not the gas evolution ceases, stop adding hydrogen peroxide once you've added approximately 30 milliliters of hydrogen peroxide. If you add less hydrogen peroxide and gas evolution ceases, you need to stop earlier, but 30 milliliters is our cutoff. Remember to stir continuously during this process. Next, we will show you how to create your ice bath for the cooling process. Use your plastic bucket and collect ice from the ice vendor. Approximately 1.5 scoops will be sufficient for this. Next, take acetone or salt, depending on which is provided on the day, and add a little bit of it on top of your ice. This will allow the mixture to crystallize at a colder temperature than what the ice necessarily is able to provide. Now place your reaction vessel in the ice for approximately 10 to 15 minutes. We will require ethanol, cold ethanol, to wash our product with. Collect some ethanol in a beaker, which you will also place in the ice bath alongside your reaction vessel. Place the ethanol you've collected for washing purposes into the ice bath next to your reaction vessel so it may cool down alongside it before you start the washing process. We will use vacuum filtration to wash our product or to dry our product, and this involves a Buchner funnel. You will first connect your Buchner funnel to the vacuum using a pipe as illustrated here, and you need to remember to clamp your Buchner funnel to the back of the fume hood as well. Next, collect a filter paper from your demonstrator or the lab manager for the appropriate size. Place the filter paper at the top of the Buchner funnel and now switch on the vacuum by turning the knob that indicates vacuum to the left-hand side. Just follow the arrows. Now you will take your reaction mixture and slightly swirl it before pouring it into the Buchner funnel. If you were not able to transfer all your product in your initial transition or your initial transfer, use some of your washing ethanol to transfer your product from your reaction beaker to your washing. You can use your stirrer rod still for these purposes, as illustrated here. Do not place your stirrer rod down on your bench. Leave it in the beaker, but now you know. You can continue this process until you have been satisfied with your yield you have obtained. If much of your product remains on the rim of your reaction beaker, you can use a dropper pipette and wash it off as illustrated here into your Buchner funnel. You can also rinse your stirring rod using the same method of the dropper pipette as you use for the rim of the beaker. Finally, after ensuring you've transferred all the product from your reaction flask and your stirrer rod, then wash with the last bit of cold ethanol that you have left, and you should be left with a very dark green, almost black crystals or powder, which is your cobalt Ac3 complex, which we will now dry in an oven. Disconnect your Buchner funnel from the vacuum, ensuring that the vacuum tap has been closed, and then transfer your product to a watch glass so that we may place it in the oven. You can use a spatula or slightly try and tip your product into the watch glass first, which will usually result in you using the spatula in the end. Place your watch glass in the oven at 110 degrees and allow it to dry for between 10 and 20 minutes. You will need to judge this yourself depending on how wet your product was when you placed it in there. Next, we will start with our purification steps. First, in this, we will need to collect toluene. Again, using our measuring cylinder and a funnel, we will collect toluene from the reagent fume hood. Place your toluene on a hot plate and cover it with a watch glass to start the boiling process while your crude product is drying in the oven. Once your crude product has sufficiently dried, you may add it to your toluene, your boiling toluene solution. This will result in a dark, deep green solution. For the next filtration, we will use gravity filtration. You need to ask yourself why. Fold your filter paper as illustrated here in the video and place it in a funnel which has been safely secured at the back of your fume hood. Your funnel, safely secured in a clamp at the back of the fume hood, will be used as the top part of your filtration system, along with a beaker at the bottom. Take your hot solution of toluene and your crude product and filter it through the filter paper, allowing it to drip slowly. Do not overfill, because then, of course, you will have spillage. Next, while your product is filtering, collect your 70 milliliters heptane, again using a funnel and a measuring cylinder in the reagent fume hood, which you will use to precipitate your product. You will also use an ice acetone or ice salt bath, which you can also prepare in the meanwhile. Place your filtrate in an ice bath and add to that the 70 milliliters of heptane in incremental solutions. Incremental increments, my apologies. This will allow your product to crystallize out. To aid in the crystallization of your product, you can also use a process called seeding. This is done by scratching the bottom of a beaker with a glass rod. This creates little glass particles along the bottom of the beaker, and this creates a sort of a template for your crystalline product to crystallize on top of, enforcing or motivating crystallization. After about 15 to 20 minutes of attempting to form seed crystals and form your product and allowing it to crystallize, you can filter once again using vacuum filtration, hence your Buchner funnel and using your filter paper. You can use a bit of heptane to transfer more of your product from your beaker to the Buchner funnel, should they be left in the beaker, but trying to swirl and get as much in your initial transfer to filter. Your product should now be dark green, but not as black as before, since we have now removed the impurities that were present in our crude product before we placed it in the oven the previous time. Finally, transfer your product to a watch glass using this new technique that we illustrate here. It's much easier than what we previously showed. And then you will dry your product again in an oven at 110 degrees for approximately 15 to 20 minutes. But of course, as always, you need to use your own judgment to determine whether or not your product has dried sufficiently. Remember to take note of which one is yours when you place it in the oven. A final note is on waste management. Always ensure that you place your waste in the correct waste container. So whether or not it was your heptane waste, your filtrate waste, or your washing waste, for each step of your experiment, there will be a waste container labeled appropriately, and you just need to follow the correct labels as illustrated here in the video. Finally, remember to weigh your dried product after collecting it from the oven. You can use a new watch glass, tear the scale, and transfer your product to this new watch glass to get the correct mass. I hope you enjoy this experiment, and may your crystals turn out to be a beautiful dark green as shown here. Thank you for watching.